Hello students, in today's class we learn about spur gears. Before that we need to know what are the types of gears present in the market. These are the types of gears present in the market: spur gear, helical gear, rack and pinion, bevel, meters gear, worm gear, worm and worm gears, screw gears, internal gears. So there are many types of gears classified on the types of use, classified in the types of position where it is being used, classified to its shape, everything. Let us take one example. What is spur gear? Now you could see that it's the teeth of the gear. This is the teeth of the gears, and this is the center line of the gear. They are parallel to each other. When they are parallel, when the teeth of the gear and the center line is parallel to each other, this is termed as spur gear. But whereas the teeth of the gear and the center line are at angled, then it is termed as helical gear. Now, when this spur gear is cut from the center through the radius and stretched to a single line, it is termed as rack. And this is same the thing like this is called pinion. Now this is the bevel gear. This is the center axis of center, and this is your teeth, which is pointing towards the center or the axis. Now this combination is termed as rack and pinion or gear 1, gear 2. Now you may ask me, so there is written over there that it's also rack and pinion. Yeah, this is also termed as rack and pinion. That's you could take it as gear 1 and gear 2 is meshing to each other. So there is no any problem. Number 2, why do I need a gear teeth analysis? Why not other parts? Because we could see that the teeth is the things which gets meshed with other teeth and transmit energy from this motor to this motor. So this part of the motion to this part of the body. So hence while meshing they generates enormous amount of stresses. So we need to calculate the stresses. So what should be our main motivation? That how to calculate the stresses, what should be the basis of calculation of the stresses. Now this is our cantilever beam. Now why have came directly to cantilever beam? Why not other beams? Because the cantilever beams can mimic the teeth of gear, any teeth of gear of any gears. Now let us understand what is the basics of cantilever beam. The cantilever beam is hanged outside with one end fixed and one end hanged, overhanged. Same, if you see that gear teeth, or like this over here, the gear teeth is fixed over here and it is hanged outside. So this teeth is nothing but mimicking the cantilever beam. That's why we are considering a cantilever beam. Now let us start the calculation. So as we can see, there is a force PR, alpha, so on, everything. So what is this, right? Actually this is nothing but the meshing of gears. What happens when two gears mesh? As we can see, there are two gears are meshing. There is a point of contact. As we can see over here, there is a point of contact. So what happens if it's a point of contact? What happens if it's a point of contact? The point of contact it tells us about, as we can see over here, the point of contact. Now this, what happens in the point of contact? There is a force acting to each other. What happens if a force acts on there? So there will be a stress generation, as it is shown over here. This is the finite element methods explanation, or it's a simulation explanation by COMSOL physics software. So it helps us to understand that there is a force or stress working over here. Now So to mimic these things, let a force Fp is working on here. So it's the isometric view of the teeth. Okay, let us clean the screen. Okay, this is the isometric view of the screen. Okay, what happens? This is the a force F is acting on this portion. Now, what happens when force P is acting? It acts at a certain angle called alpha. What is alpha? You may consider alpha over here, or you may consider the alpha, this one over here also. That depends on the conditions, as well as that depends on the meshing types. How is it meshing, and what types of gear it is meshing. Now, what happens? This alpha denotes the pressure angle. Now, if a force is acting at an angle alpha, what will happen? Two components will come. One will be P cos theta and one will be P sin theta. As we know from the earlier classes, or in our earlier semester, we have learnt about this, that if it is P at an angle theta, then it will be P cos theta and it will be P sin theta. Fine, clear? Now let us observe from the front view. This is nothing but this one. When we are observing from the front view, we could see that a force P is acting over here, and for which two forces are generating. Let us consider this to be alpha. The pressure angle. What will happen? It will be cos component, and this will be your sin component. So you may ask me, sir, it is given over here. It is the force is acting over here, but you are showing over here, that is inside this. Now this is how it comes. We are showing this force can be stressed inside, or in other words, as per our theorems of transmissibility, we could shift the force to without changing its direction. Without changing in direction, we could change the force in its line of action. So the force was actually working over here, but we have changed it to over here. So that's why there is an alpha and PR and PT. So we know that what happens if a force will work over here, since it's a cantilever beam, so we could observe this thing. This is nothing but a cantilever beam which is observing a force, which is experiencing a force, and hence that's a bending. Now that's a very problematic thing for a gear or teeth or anything which is in an action of cantilever beam, or which supports cantilever beam calculations. Now since gear teeth supports cantilever beam, we have to keep in mind that how can we encounter these things in simpler form. That's why we have to calculate the bending stress. What is bending stress? We have learned from our previous classes. Bending stress is my by I. M is nothing but the bending moment, calculated bending moment, that is, or in other words, the approximated bending moment, and y is the vertical distance. Y is the vertical distance away from the neutral. Now y is the vertical distance from the neutral. I is the moment of inertia of the neutral axis. Now let us go back to the diagram and let us understand what is our point of consideration, what is our neutral axis, and what is so on. This is the point from where we will start our calculation, because since it's a symmetry of this and this portion is symmetric to this one, so this force, we have to understand, for bending of a body, this PR will not make any action. It will not play any action because it is directly getting outside or from this way. So it will not make any action, or in other words, this PR will go these things. But if a force PR, a PT, that is over here, works over there, that means this portion will bend, just like this one. So what will happen? Let us go back. Therefore, this is not our cup of tea. We don't need cup of tea, in the sense we don't need PR at all. PR is not right now a consideration. We have to be patient about PT. PT is nothing but the cos component of the angle. If we consider this as alpha, if you consider this as alpha, this will be the sine alpha. Vice versa, this is the same thing only. Now, PT, since it's moment, so we have to consider the moment. What is moment? What we have first? M moment. What is the moment? PT into H. Fine. So MT will be PT into H. And what will be the Y? Y is the point of neutral axis. What will be my neutral axis? My neutral axis will be this one. This one. This is how much? T, and this is where the body is bisected in two segments. That means this is my neutral axis. The neutral axis will be T with respect to T, that is T by 2. Now, last but not the least, inertia of the around the neutral axis. What is the inertia? Inertia means this rectangular surface or the contact surface of the teeth to the body is nothing but a rectangle. So we know what is the inertia of the body. So what is the inertia of the body? Is nothing but BTQ by 1, 2. What is B? Now let us go to back. B is nothing but the breadth and T is the height, or you may say B is the length and T is the width. Now, putting all this formula over here in a bending stress, we could find out this one, this calculation. So scientist named as Louis came up with an idea. So why shall I do this one? Can I make it very simpler? So people came out and said, yeah, you can make it very simpler. Let us take PT in this side and bring all the components over here, like rearranging everything like in this manner. So we find out this one. So what was this? This was the last and foremost things which actually explained or changed the gear technology. So the scientist came up with this one. The name of the scientist was Louis. So what he did, he multiplied this here with M as well as multiplied here with M. So this he considered as Y, as you can see over here. Y is nothing but your Louis factor. Okay, so we could substitute Y over here and this equation becomes this. Okay, so scientists made certain number of calculations, they went certain number of experiments, and they came up with the formalized way how we could explain it. As we can see over here, what is this? This is a Louis table which actually make us easy to understand what is the bending stress or calculate the bending stress. Like if the number of teeth is 15, the value of Y will be 0.289. So who decided it? It was decided by AGMA. So I'll teach you about AGMA in the next class. So we know what is Y. So what we need to know, how Y is affecting on the beam strength or the force applied. Why am I telling the beam strength or force applied? Because SV is represented as beam strength and the force applied is PT. So what they have done, they have just rewrite the PT as SB, S suffix B, that is strength of beam or beam strength. The same thing, same in other waveform. So if I have Y, if I could calculate Y with respect to the number of teeth as it is given, so this will actually help me, to understand how much force is applied, because the module of the gear will be predetermined, the width of the gear, that is the teeth width, this is the length of the teeth or the width of the gear, will be predefined, and sigma B, that would be the permissible stress, will be predefined. So I could calculate the amount of force applied in over here, because this PT makes this gear to rotate, since the force, the tangential force acting on the gear will make it to rotate. Rather, if we go through, if we try to understand this thing, if this is a tangential force working over here and this is the center, what happens if you apply a force, it will rotate in this manner. If you apply a force on this way, this force will be transferred over here, that means it will not create any rotational motion, hence there will be no transfer of motion from gear 1 to gear 2. So that's why I have absoluted this force as stated over here, this one I have absoluted this force, because it is getting inside towards the axis. As we can see over here, PR is getting towards inside towards the axis, that means it's not creating any type of rotational, or it's not affecting the teeth strength or anything. So that's why this is our main priority, and we have to find out. It has also been named as SB. The thing is that everything is same and now and then. So what we have to understand is how it affects SB, M, B, Y. So this will be provided, this will be provided, this will be provided, and you have to calculate this from this table. Now this table will be calculated by, as I have told you earlier, this is will be calculated by AGMA. A stands for American, G stands for gear, M stands for manufacturing, and A for association. Now AGMA is an organization which makes the formulas or driving formulas, who actually works on the types of formulas as well everything which is required for gear manufacturing as well as for calculation of gear. This table has been given by the AGMA to understand the value of Y, which helps actually to calculate the value of beam strength, because if you know that number of teeth, Z is the number of teeth, you could calculate number Y. That means you don't have to do this calculation, this rigorous calculation. This is not a rigorous, but this calculation you can omit it. That means you are skipping a step, you are getting very easier. You know the Y, you have the allowable stresses from the types of material or the types of work you are doing. You know the beam, this is the B, that is nothing but your width of the gear teeth, and you know the module. You could actually calculate the module from the how it is meshing with other gears and everything. You could calculate it. So from there you can calculate the beam strength. So this is what. So this is how the we calculate the graph of beam of the stresses stresses in the gear. This is what we for one revolution, one revolution, one revolution. That is for the, so there is a 3 gears: driving gear, idler gear and driven gear. The direction of driving gear and driven gear is maintained same due to the idler gear rotating and anti-direction respective to driving and driven gear. So what happens is we calculate the stresses, the mean stress and amplitude stress, and we have plotted and got this two graphs. To calculate the effective load, that is PT or PD, this is PD, okay, effective load, or how much effective load we can actually apply and how could we change it and everything. To understand in practical way, we use this one, this thing methods. MT is nothing but the torque. We know the torque 16 by 2 pi n. Now what is PT? PT is 2mt by d dash. How can I calculate this one? Why it is like this? What do we know about MT? MT is this formula from pitch line velocity. We will calculate this one. As well as we know MT, the general formula is force into distance. What is force? Force is here. Now if you take it in this manner, if you take in this manner, this is the force, this is the length, and this is 2. So what is happening here? PT is the force and the distance is d by 2 into. So after rearranging I get this one. So how can I how I have told you this one is d by 2. This is from this to this, it is d by 2. This will be d by 2. It will be d by 2, d dash by 2, or pitch line velocity is calculated d by 2, and this is PT, or in other words this is d by 2. This portion from here to here, it will be d by 2, and this is PT. So what I can do, I could find out the torque PT into d by 2. After rearranging I could get this one. So what is the factors which drives more? That is CS. It is termed as service factor. The service factor is nothing but the ratio of maximum torque by maximum torque to rated torque. That is that help us to understand how much it will work and what are the factors related to it, how it will work. As you can see, service factor can be determined by these things. This is the driven gear and this will be the driven gear, or this is the driving mechanism and it is the driving mechanism. If they are doing a lower form of work, then this will, and as well as these two are doing a lower form of works, that is the work done by both the driving and driven end is very normal, then we can take 1. If it is very maximum, we can take 2.25. So what is minimum, what is maximum, you will see in the question, as well as you can get from these things. What is uniform, what is medium stock, and what is heavy stock, as well as what is uniform, what is light stock, and what is there. This is the driven this is the driving characteristics, that is nothing but this one, and this is the driven characteristics. That means it will drive this one. We know driving machine makes the driven machines drive. So we have to see what is the factor. Similarly, we find out the velocity factor, that is CV is equal to, it depends on the velocity. If it is between 10 meter per second, pitch line velocity 10 meter per second to and 20 meter per second, we could use 3 by 3 plus V. And for similarly for for more than 20, we could use 6 by 6, and not more. Sorry, I am very sorry. If less than 10, it will be 3 by 3 plus V. If more than 10 and in between 20, it will be 6 by 6 plus V. And if it is more than 20, it will be 5.6 by 5.6 plus V. So what will be the V? V is nothing but a pitch line velocity pi dn by 16 to 10 to the power 3. So what is the efficient loading? Efficient loading is CS by PT by CV by PT. So this all are the formulas what we have derived by number of works, number of experimentation. So this will help in our classes, in the coming classes. Number C is the deformation factor. How much it will deform, that depends on the elastic limit, or you may say the modulus of elasticity. If it's a ductile material, but if it's a brittle material, it will not work in that accordingly, because it is only valid for ductile. That way C is equals to K by 1 by EP plus EG. K is nothing but your constant depending on the tooth forms. So this is a how the teeth has been formed. This is a cross teeth forms, or it's a stud forms, which is a V, or it's a squared. Everything what we have to see, we have to understand and we have to calculate this one. We'll go in details in coming classes by solving sums, how it works and what are the factors. So to avoid failure, we have to maintain this criteria, that is SB. What is SB? PT. What is PT? The applied load, or SB is also termed as beam strength, should be greater than the efficient strength. That means this should be, this is what the matter. The efficient strength should be lesser than the beam strength, or PT. Okay, that means we have to increase it. We have to have a maximum beam strength for beyond efficient strengths. So after calculating these things, as I have told you, we can also deduce. Again, they have done more deductions, like D is equals to mz. So what is mz? Module. We know that module equals to D by Z. Module equals to D by Z. So they have these two have been multiplied, and this formula has been has been substituted over here. We get D is equals to mz. After putting everything in to understand in the understandable area, we have deduced this one. What is this one? MB has been substituted by M and then multiplied by M. So and SB is by SUT by 3, as I have told you why it is SUT, or why do we use SUT or SYT, how it depends on the material. If it is we generally use SUT if it's a brittle material, and if it's ductile material, we'll use SYT for maximum safety. It's not a hard and fast rule, but it's very good to do. It's mandatory. It's a standardization used by the scientists and everywhere. So after that, we have deduced the module in this way. Because we have to find out the maximum allowable module, which could actually help to determine the actual scenario. So what is that module? M module is equals to 60 into 10 to the power 6 by pi kilowatt. That is power. Okay, power. CS, this is nothing but the service factor. FS is the factor of safety. It's a FOS, in other words, factor of safety. Z is the number of teeth. N is the RPM. B, width of the gear. M is the module. CV is the your velocity factor. SUT we know, that is the beam, that depends on the material. It may be ultimate strength or anything. And Y is your Lewis factor, or what is as we have stated earlier. So after that, we could find out the calculated module required for a gear, which would actually help us to design a gear in efficient way. So thank you for listening, and if you have any problem, contact me. I'll be very happy to help you all in any terms. So call me or mail me in my class. Thank you.